All right, guys, we're going to talk more simplifying today. Okay, so on Friday we talked about your first identities, and we talked mostly about like breaking things down into sines and cosines and hoping things cancel out, right, and leaving you with like one term. So we're going to talk a couple more strategies today, just to give you a reminder. Okay, so when you're simplifying, you're not solving for anything, right? You're just trying to break your expression down into the most simplest form that it can. Okay, so typically that's trying to get it down to one term. Maybe it's not one term, but it's the most simple that you can make it. Okay, so again, you're not solving for anything specific, you're just changing the form. Okay, so a couple strategies. So first one is what we talked about last week. So strategy one, write the expression in terms of sine and cosine. Okay, that's always kind of a go-to. Just see if you can break it down as simple as you can. So like this one, kind of like what we did last week. Cotangent, okay, we can write that. Yes, it's 1 over tangent, but like let's break that down into sines and cosines. So cotangent is cosine over sine. Okay, and then secant, that's your reciprocal, is 1 over cosine. Right, when things are right next to each other, you're multiplying. So hopefully you notice that these cosines cancel and you're left with 1 over sine, which yes is one term, but like break it down as much as you can. 1 over sine is just cosecant. Okay, so again, that's not too much different from what we did last week. So maybe if the sub can pause the video, you guys try number 2, and then we can hit play and check it. Okay, so again, number 2, this is all just kind of one jumble, so I'm just going to break it up if I can. Okay, so secant squared, that's the same as saying 1 over cosine squared, theta, right, times, now sine squared is already sine, so I'm just going to leave that as sine squared. Okay, now that's like it's over 1. So if you want to put these together, that's sine squared over cosine squared. Yes, you have to put the thetas. Okay, so sine squared over cosine squared. Well, sine over cosine is tangent, so this is just tangent squared. Okay, so that's strategy 1. Break it up into sines and cosines. Okay, sometimes that may not help you very much. It might just not get you anywhere. So another strategy might be to factor. So let's just do a little factoring practice first. Okay, this has nothing to do with trig. So a squared minus a squared b. Okay, you can take out a GCF. Right? They both have an a squared. So this one would look like a squared and then 1 minus b. Right, that's it. Okay, factoring could be, finding what multiplies and adds. Algebra 2, I always set this up. So what multiplies to 1, what adds to negative 2? Well, that'd be negative 1 and negative 1. Okay, this one does start with a 4. So this would have to be x squared minus 1, and then another x squared minus 1. Okay, now technically this one you can factor more, because that's difference of squares. And actually this one's the same. So technically, if there's 2 of those x plus 1s, we could write x plus 1 squared. 2 of the x minus 1s, we could write x minus 1 squared. Okay, but again, just factoring. Okay, so strategy 2, if breaking things into sines and cosines doesn't help, you can also factor things. Okay, so this one, you could break this down to sines and cosines, but I'm not sure how much it's going to help. And it might just be a longer way. I'm not saying you can't do it, because you can, but it might just be a longer way. So kind of what I want you to start recognizing, if you have like a plus or a minus, maybe see if you can take something out. Okay, so these both have a sine squared in them. So I could take out a sine squared. And figuring out what's left, this first part would be cotangent squared. Second part would be just 1, right? That's taking a sine squared out of everything. Okay, so again, could break this down to sines and cosines, but the fact that there's a 1 here, that should kind of trigger me to go look at my identity sheet, because there are things with like 1 plus, 1 minus, right? So cotangent squared plus 1. Kind of sounds familiar. Look at this one right here. Yes, it's not in the same order, but it's the same thing. 1 plus cotangent squared is the same as cotangent squared plus 1. So this right here actually just becomes cosecant, okay? And then this is still sine squared, cosecant squared, sorry. You're multiplying, and now this is kind of like before. Oops, forgot my x. Sine squared times cosecant 1 over sine squared. Oh, look at that. This is actually just going to become 1. Okay? All right. And yes, there is another way you could have done that, right? You could have broken this down to sines and cosines, and then you'd end up using another identity anyway. It's not the only way, but it is a way. Okay? So again, we're just working on this factoring strategy. Okay, so let's do the next one. This is kind of like the one above it. So I know this gets a little tricky, just take some practice, but pretend like this said x to the 4th plus 2x squared plus 1, right? You got the 4th, you got the squared. Okay, if you factor that, that would be like x squared plus 1, x squared plus 1, right? 1 times 1 is 1, adds to 2. Those x's are just tans, okay? It's tangent. So this is tangent squared plus 1, and then another tangent squared plus 1. Okay, if you multiplied that out, that would get you back up to here. So again, I see something with a plus 1. I'm going to go see if that's an identity. Tangent squared plus 1. Yep, that's right here. So tangent squared plus 1 just is secant squared. So that part becomes secant squared. This part becomes secant squared. So when you have something squared times something squared, this is actually just secant to the 4th. Okay? So break down to sines and cosines. Try to factor. Okay, one more strategy. Everybody's favorite, fractions. So little review here. Okay, if I wanted to add or subtract fractions, you have to have a common denominator. Right? So here's one without any trig in it. So I have 2 over 3 plus 1 over 4. Okay, I could get those both to be 12. So I'll multiply by 3 over 3 on the second fraction, 4 over 4 on the first, right? Whatever you do to the bottom, you have to do to the top. So this would be 8 over 12 plus 3 over 12, which is 11 over 12. Okay? So trig, it's going to be the same thing. Okay, so here's strategy 3. Add, subtract, or multiply. Use a common denominator to add or subtract fractions. Okay, so this one. 1 over cosine plus 1 over sine. I can't really break that down any more than it already is. And these, I could do like the reciprocal functions, but then I just have secant plus cosecant. And that doesn't really do me any good, right? So let's see if we can add these fractions together. So if I want them to have the same denominator, I'm going to have to multiply them by the other term, right? So this one would be cosine over cosine. Whatever you do to the bottom, you have to do the top. Sine over sine. So if I put the first one together, this is sine theta over sine times cosine theta. Okay, if we do the second one, it's cosine theta over, same thing, sine theta times cosine theta. Okay, don't cancel things because that's just going to get you back to where you started. Okay, but now I have a common denominator, right? So I can make this into one fraction. Okay, so I just put it together. I made it into 1, and this may look like some identities. Excuse me. But it's really not, right? Sine squared plus cosine squared is 1. But on the top here, I just have sine plus cosine. That is not an identity. And this, I really can't break this down. Please do not do this. You cannot do that because of this plus sign here. So actually, this is the furthest I can break that one down. It doesn't get broken down very much. Okay, but that would be writing it as one term. Okay, so that's kind of a weird one. I'm going to skip 9 just for time's sake. Let's go over to 10. Okay, 10 is one where this is already a fraction. Okay, I could break this down to sines and cosines if I wanted to. Okay, I could totally do that. If you do that, you're going to have some fractions within fractions, which is fine. But here's another thing you can do. I can split this up into two things. Okay, so this would be cosecant over cosecant. Oops. Minus sine over cosecant. You're allowed to do that, right? I just broke it up, kind of split it up into two. The reason I did that is because of this, right? Cosecant over cosecant, that's just going to be 1. Okay, well, what's sine over cosecant? I can write that as sine over 1 over sine. Ooh, I'm just going to take this part and kind of do this off to the side. Remember, we don't divide by fractions, we multiply by reciprocals. So this actually just becomes sine squared. So this is 1 minus sine squared. Okay, again, I see a 1 in there. That's going to make me go look at my identity sheet. So 1 minus sine squared. I may not see that on here, but remember in our notes the other day, we did take these and rewrite them. So this is actually that first Pythagorean identity. If you minus sine squared, 1 minus sine squared is actually just going to be cosine squared. So that's all this one becomes, cosine squared. Okay, remember we wrote those. We wrote these, we wrote these, we wrote them all. Okay, it's just changing the forms. Okay, I'm going to stop there. Okay, so there is a lesson check for you guys to try. We're going to keep going and do more of this stuff tomorrow and the day after. Just takes some practice, right? It just really takes practice getting familiar with your identity sheet, knowing the things that are on there, kind of what to start looking for. But use those 3 strategies, okay? Break down to sine and cosine, factor, or use your fraction stuff, okay? Common denominators, okay? I'll be back tomorrow. We can answer any questions, but you guys try the lesson check, okay? Thanks, guys.